Hello, IM3 students. Today we're going to begin 13.4, which is on compound interest, and we will be doing day 1 right now. I will be able to model the value of an investment that earns compound interest, and that will be our objective today. So let's go ahead and take a look at the interest compounded. So the first type of interest that is compounded is once per year. So when you put your money in the bank may only just do one-time calculation of the interest. And so this is once per year. This is the formula. V for the value of your account is equal to the P times P is the principal. 1 plus T, again, notice that this is the growth rate, the growth ratio, remember, 1 plus R, and then T is again in years. So this is the same formula that we use to find any value that is increasing. So we're just applying some appropriate variables to make it more appropriate, like V for value instead of F of T, P for principal, because we're dealing with money in the bank, right? So here we're specifically talking about accumulating interest in the bank. And so let's remember that formula, which is not a new formula, it's just different variables, okay? So in the first example, Miss Sierra invests $6,000 in an account that earns 4.25% interest, compounded annually, which means once a year. So this is the formula that we just learned that we are using once per year. So once per year, you use this formula right here. So we're going to write an exponential growth model that represents the value of the account at any time. So we're going to use V of T is equal to, let's start with the formula, P times 1 plus R to the T power. So that's the formula that we're going to use. And let's go ahead and substitute the numbers from this problem. P is the principal amount, which is 6,000 in this case. 1 plus R, the interest that is earned, is 0.0425 to the T power. And of course, you can combine it into 1.0425 to the T power, and that will be V of T. So that's the function for any time T. B, use a graphing calculator to find the time that it will take for the account's value to reach 9,500. So to understand this, we're going to set up the equation just like what we did in the previous problems. So we're going to set we want to know when the account will reach 9,500. So we're going to let V of T equal to 9,500. And we're going to copy the rest of the equation down. And so now we are going to, now notice that 9,500 and 6,000, that's a pretty big number. So if you don't want the numbers to be really big, you can go ahead and perform a simple operation that will help you reduce the problem. So if you can divide both sides by 6,000, that will get rid of that. And you have reduced 9,500 to over 6,000 to 19 over 12. You can use your calculator to reduce the fraction. And that should equal to 1.0425 to the T power. So we're going to go ahead and let y, two separate y's, equal one side and y equal to the other side on your decimals. So y equals 19 over 12. And the next one is going to be it's just going to be 1.0425 to the x power. So this is the equation. And notice that right away you'll see that they meet at this number right here. So the x value is going to determine the time. So that's t equals 11.04 years. And that's about, so t is about 11 years. And that is when the bank balance will reach 9,500. And so that's the end of that problem. Let's try another one. You're going to try this problem because it's a try it problem. You're going to go ahead and try it. Go ahead and pause the video. Try it before you watch the solution. Hopefully you've had a chance to try the problem. Katie invests $1,000 in an account that earns 5.5% annual interest. So we are dealing with annual interest. That's one time. So write an exponential growth model that represents the value of the account at any time t. So again, V of t equals P times 1 plus R to the t, and principal value is 1,000. That's 1 plus the ratio is 0.055 to the t power, and so V of t is equal to 1,000 times 1.055 to the t power. And then again, part B says use a graphing calculator to find the time it takes the account to double. Well, what does that mean? If you start with 1,000, you want it to double. You want to end up with the account value of 2,000, right? And then bring the rest down. And again, 2,000 and 1,000, those are big numbers, so I can just go ahead and divide by 1,000 to get rid of that big number. So I have 2 is equal to 1.055 to the t power. I'm going to let y be one side and another y to the other side. So go ahead and use the graphing calculator to find the answers. The graphs, y equals 2. And then second one is y equals 1.055 to the x power. And once again, they are going to meet right here. So it is approximately 12.95 or close enough to 13 years. So it's going to take 13 years for the money to double. And that is the end of the problem. So that was the interest accumulated once a year. So as you can see, there are different types of accounts, bank accounts. Sometimes, they will calculate the interest like maybe half a year, or maybe every quarter, or every month, or even every day. So let's take a look at another formula that is more suitable for any type of compound. So this formula is a do-it-all. Basically, this is the formula which even works for one time a year, because n just equals to 1, and that's why it disappears and we just have 2 to the t power. But technically, there's an n right there. So if we add the n here and here, that will cover it all for any type of compound. And we just need to understand terminology. So let's take a look at the different ways of calculating interest in a year. So if someone says if the keyword is quarterly, that means every 3 months, so n should equal to 4 in this case. Annually means every 12 months or once a year, so that's why n equals 1. And then semi-annually is every 6 months, or n equals 2. Monthly means every month, that means n equals 12. And daily means every day. So we're going to assume that there are 365 days in a year, so n equals 365. So those are the keywords that you're going to identify when you are trying to evaluate or find out the interest earned on any certain account. So let's take a look at this example. Jim opens an account with $6,000 that earns 4.25% interest, compounded semi-annually. So you see that keyword right there? Going back to semi-annually, you know that it is every 6 months, so that means interest gets compounded 2 times a year. So we will keep that in mind. So we know that n equals 2. So our formula is going to come down to V of t is equal to P. So let's go ahead and use the same formula, times 1 plus R over n to the n times t. So that's the formula, right? So we're going to actually substitute the principal amount, which is 6,000, times 1 plus the rate, in this case, is 0.0425, divided by, remember n is equal to what? 2, because it's semi-annually. And then to the 2t up here. So n equals 2. And then simplifying this, you should get 6,000 times 1.02125 to the 2t power. Okay, so that's the equation for V of t for this particular scenario. And then B, use a graphing calculator to find the time it takes for the account value to be 8,000. So we want to know when V of t is equal to 8,000, right? So we're going to set it equal to 8,000 equals to 6,000 times 1.02125 to the 2t. And again, because 6,000 and 8,000 are so big, we're going to divide both sides by 6,000 to get rid of that. and that will give us 8 over 6, or reduce that to 4 over 3 equals 1.02125 to the 2t. And we're going to use a graphing calculator now and let the x and let both left side and right side be y's separately and see what the time is that they will intersect. So first we have y equals 4 over 3. Next, I'm going to change that number to 1.02125. 1 extra 5. So it's kind of like a flat curve right there, but you can still tell that they meet like right up. Excuse me, I think I entered the wrong equation. So instead of x, it should have been 2x. So now here's the new intersection. So it is actually t equals 6.84, or about 6.9, or just 6.8 rather. So I'm just going to say t is approximately 6.84 years. I'll just leave it at 6.84. And that is the exact time almost for the account to go from 6,000 to 8,000. End of the problem. Here's another tried problem. So you're going to try this one also before you look at the answer. Sabrina opens an account with 8,000 that earns 6.5 interest compounded daily. Ooh, daily. Let's recall what daily means. Daily means n is going to be 365 because every day you're going to compound the interest. So that's going to be a big number right there. And then write an exponential growth model that represents the value at any time. So it's going to be v of t. We're going to use the same formula, p. You should have it memorized by now, right? 1 over r divided by n to the nt. So the principal amount is 8,000. 1 plus the rate is 0.065. Divided by 365 to the 365t. And that is basically what you should have. We're going to do the math. You can divide all of this, add it together and divide. You should have something about 8,000 times 1.000000178 to the 365t. Okay, so that's the equation. And part B says use the calculator to find out when this account will be reaching $20,000. So V of T, you wanted to set it equal to 20,000. So we're going to set 20,000 equals 8,000 times 1.0000178 to the 365t. And again, we don't want such big numbers here, so we're going to divide 8,000 to make it smaller. 3 zeros will cancel out, and this will give me 5 over 2 equals 1.0000178 to the 365t. So again, we're going to let the y's be each side separately, and let's see what this intersection is going to be. So we're going to reduce that to, what did I say? 5 over 2. And then here is 1.0000178 to the 365x. And here is the intersection. So it looks like it's going to be 14.1 years. So I have t is approximately 14.1 years for the account to reach $20,000 for that interest rate. And that is the end of the problem. Here's a discussion. What is the difference between simple interest and interest compounded annually? So simple interest is interest earned on the principal, and interest compounded annually is interest earned on the principal and on the interest. So your interest is also earning interest. Instead of just your principal is earning interest. So basically that is the difference between the two. And so that is the end of this discussion and the end of the lesson as well. So hopefully you guys understood how to find the values of different types of accounts accumulating interest on a different kinds of scenario: daily, weekly, bi-monthly, monthly, all those sorts of different ways of earning interest. And that's it for this lesson. And go ahead and get started with your assignment. I'll see you next time. Bye. Have a nice day.